Alright, so in today's screencast I wanted to cover the topic of testing, specific on pyVmomi, but testing in general. In testing, you want standalone, automated, and deterministic tests. Now then, what are we talking about testing? Virtually anything that you write today as a developer is going to be your code sandwiched between a core system, in our case, the Python runtime and Python libraries that we would consume in order to accomplish the goals of the library, and then the end user or user's code. In this particular case, we're writing a library that provides API calls that users would then build in order to create their own scripts or services or daemons. If you happen to be writing a web application, your code could be something built, a web application, for example, built on top of Django. Django would then be using core Python libraries in order to accomplish its goals. So when you're testing, it's not user code on the other end. If you're a web app developer, it's actually users' web browsers on the other end, and those web browsers will be doing things like clicking things and things like that. Then your problem is interesting because there's no code to represent on that end. So you need something like a Selenium in order to be able to run automated testing or run fake browsers and pretend to be running around your web page and clicking things. So you have no code to represent. If you back up the stage one level to where you're writing something in, say, Django or a web framework, and you're writing a plugin or something like that, say a plugin for Grails, then your code is not going to actually be clicked on by people in the web browser. It's going to be used by people who are writing web applications. And those folks will write code around your plugin. So the user code will wrap your code. You will anticipate the scenarios that your code will be written in, and those scenarios will be what your tests are in. Now, your code is your code. You don't care about the underlying fundamental libraries. For example, if you had Gorm or SQL Alchemy underneath you, you could write mock objects to represent the calls that those underlying libraries would have, and they can throw the exceptions you want to be able to handle, or they can have the different types of return types that you would expect to happen. So that's your code in the case where you're sandwiched neatly between an underlying framework. There's your code, and then there's an end user code. There's the special case when you're writing the web application. There's no code on the other side, so you have to write things in Selenium in order to drive automated web testing that way. But then you have problems of being way far on the other end, and that's kind of where we're at when we're talking about pyVmomi. pyVmomi sits right on top of HTTP transactions. What's beneath us is basically the web socket. The Unix socket is directly beneath us. We're exercising through the internet a set of SOAP API calls. So there's no thing to mock underneath us. We're almost right on the middle. Right above that is our pyVmomi code. It creates all of the API calls, and it hides the fact that you're going over the network in order to acquire most of these objects and properties. And then we can easily make guesses about how users are going to string together use cases of our code base in order to build their applications. So in our case, what do we mock? So there's VCRPY in Python. There's Ruby's VCR library, if you happen to be in Ruby. And if you're anywhere on the Java platform, I'd recommend Betamax. What this class of testing library does is it records and replays HTTP interactions by recording them to a pre-recorded or preset of cassette files. And cassette files are effectively fixtures. To give you an example of what one of these files looks like in the pyVmomi codebase, we have identified this directory, fixtures directory, for storing these. And here's a basic connection cassette. And they're stored in YAML, yet another markup language. And in here, if you examine this, you can see the transmit and response scenario or use case that we're examining in this particular test. Now, when you're creating a patch to pyVmomi, I want you to follow these rules of setting up a fixture-based test for every pull request that involves adding a feature or fixing a bug. Here's an example of a bug issue that came up on the pyVmomi library. Folks are reporting a index out of bounds issue on the library, and right here someone has very helpfully provided me with sample code to produce these of this screencast. This is a perfect bug. We have someone who has described a problem for us. Someone else has come in here and provided me with a sample script and some sample code that reproduces the issue. They're claiming that by the time you get into here, the pyVmomi library is going to throw an index out of bounds problem. So, in order to test this, I have set up a vCenter server appliance running at this IP address. I have mapped that IP address in my hosts file to the alias VCSA, and you can see here I actually have multiple ones of these, multiple entries for this. So this is an entry in the hosts file. And I do this so that way in my tests I can reference VCSA instead of the IP address. Do this so that way the IP address for my virtual appliance doesn't end up recorded inside the fixture itself, because that's not salient information. In addition to that, I have also gone into that vCenter server appliance, this vCenter server appliance, and created the user my user with the password my password. And this is so that way no production likely usernames or passwords are included in any of the recorded fixtures, because the fixture is going to record everything, including the submission of username and password. That's something to be cautious of when you're recording these types of fixtures. So in order to create this test, what we're going to do is we're going to say new Python file, and we're going to by convention call this test container view. And we'll get a .py in the end. Never include the author, at least I don't. And I'm going to admit to having Julia Childs up some of this a little bit, so some of this has been prepared off screen. I'll go ahead and just paste in some of the library includes that I know I'm going to need. This is a unit test, and we're going to use the @exit protocol. We're going to be including the fixtures path, which incidentally comes off of the tests path here. I've actually coded up a little bit of helper function in order to get the relative path to the fixtures, so that way you can get the fixture tests to run in any environment. And I'm going to pull in logging, because I'm going to turn logging all the way up to 11 in my test setup. And again, cheating heavily, I'm going to pull down the setup for us there. Alright, now I know that in order to run the test, I'm going to have to connect using pyVmomi, and then I'm going to have to at some point get Vim objects or VIM objects from the interface. So let's go ahead and actually write our test. So if I'm going to exercise this bit of code as described here, they're going to log in. They used Smart Connect. Hardly seems important for our particular purposes, because you're well past connecting after you've started these tests, but I'm going to use Smart Connect anyway. They registered disconnect. Maybe that has something to do with it, probably doesn't. They're going to retrieve contents, get the data object, create a data center object view here, create a data center object view here, and then they're going to loop through all the data centers. So that's the salient aspects of this particular test. So we're going to say test basic container view, and I have, again, Julia childed up some of this here. Here's the basic connector string I use from inside my my tests. VCSA, remember, aliased to this vCenter server appliance in my Etsy hosts file. The user, my user, and the user, my password exist on this VCSA virtual center server appliance. That gets me my service instance. I'm going to register for disconnect just in case there's some sort of strange interaction with disconnect. I'm going to retrieve the contents, the service contents, and make sure that's actually spaced properly. And then I'm going to build the container view representing or listing out the data centers. So there's the contents listing out the data centers, a little strange formatting in here in order to get everything to fit under 80 characters. And then what we're going to do is we're going to loop through the data centers, get their data stores, and I included pprint in here, so data stores would print. And then, being a good citizen, when you're done using a view, you should always destroy your view. So let's put the destroy statement in here. And there you go. So I can run this, right-click, and hit run. And this runs, everything's green, nothing failed. So far we've failed to produce the issue that the user was seeing. So I can't reproduce this issue. So I'm going to mark this issue non-reproducible. But we've gotten some interactions now. Now, so far we have this nice unit test. In order to run this unit test in an automated environment, I would need to have this vCenter server appliance running, or a copy of this, with roughly the same same infrastructure. Now, this happens to be running VC Virtual Center Simulator on it. So it's simulating a much larger inventory than I actually could possibly represent on my laptop. This particular vCenter simulator happens to be running in my VMware Fusion environment. And it's taking about 8 gigabytes of RAM and a few 10 gigabytes of disk space. This could be an acceptable testing environment. But that's not a standalone testing environment. Now I have a dependent testing environment, and this is truly an integration test at this point. What I need is a standalone test that doesn't require the back end. So this is the point at which we bring in VCRPY. So I can say VCR.useCassette, and by convention, we use the name of the test to represent the cassette, or the name of the cassette to the test. And I'm going to put YAML on the end because these are all YAML files. And I'm going to put in the path to where we want to store and the fixtures. So it's the fixture path. And I'm going to say record mode equals once. So what this will do is when a file named basiccontainerview.yaml is not found, VCRPY will play the transactions against the actual Unix socket looking for HTTP transactions. It will then save those off into the YAML file, and then the YAML file will be used thereafter. So let's just open up the fixtures directory. Notice the files in here now. Here's the container view test. I'm going to say run. And you'll notice I got a new file. This is the YAML file for those connections. This is vital. I'm going to say git add. So I'm going to add this YAML file along with this test. So this is the test. This is the fixture for the test. Now, if we wanted to be really paranoid, really nicely paranoid, we'd change this word from once to never. And now what will happen is never will VCRPY send an HTTP transaction across the actual wire. And instead, from now on, whenever we're running this test, we're going to play back over a mock copy of the Unix socket. We're going to play back these contents as if they were actually happening over the internet. And now our test is standalone. And incidentally, if we wanted to create a test where something failed, and something failed in a way that's not easily reproducible, like for example, if a disk drive caught on fire and something failed, or some other sort of interesting hardware-based failure occurred, if we know the general form of the XML messages that are being sent back from vCenter, we can enter in any one of these types of system, or any one of these types of cassettes, and we can actually doctor them. So for example, in one of these change sets that we're currently in the process of reviewing, I've actually gone into the YAML and I've edited it to provide a unknown license problem fault. This is just an unknown type of fault. It's just a class of fault. This is an example of a class of this fault, of this unknown license problem fault. Another example might be if you had some interesting esoteric problems with chipsets that were extremely difficult to reproduce. If ever someone were to use VCRPY, create a test to run, build the cassette, and then send me the cassette with this type of recording in it, I could then program around that particular type of fault and create a pyVmomi set of abstractions that could reasonably deal with that fault. I'm not saying that we would necessarily fix something that was broken that wasn't the fault of the pyVmomi library, but now we can at least see the kinds of failure modes that people could have. Another example of what we might do with this, of something that you could do by doctoring YAML files that would be a very difficult to reproduce situation, would be what happens if a session dies in the middle of a set of transactions, and how would you properly model that, and can you get your client code to behave appropriately should there be a session failure. The ultimate goal in all of this is to create tests that are standalone, automated, and deterministic. And armed with the right sets of tools, any programmer can create a repeatable set of tests to handle just about any situation. And if you do this, you create more robust and better decoupled software. Software that's easier for folks to understand when something goes wrong, what went wrong, and when they need to figure out how to use something, how do I use it. Thanks for watching.